Well, one important upshot from the recent replication crisis stuff is that you don't have to impute bad motives
Hmm.
or think that there are nefarious actors to understand why, if certain biased structures are in place in the research design to publication pipeline, that a side effect of those bias structures will be that you'll have a lot of research that's unreliable. And so that's why it's so important to address this, because I think a lot of scientists maybe feel that I mean, I'm a scientist. Half of what I do is science. And I collect data and I try to design experiments to test hypotheses. And I care about whether I have the right answer. And I work with other scientists who are very, people with a lot of integrity who really care about getting these things right. And so, it's not to impugn any individual scientists. It may sometimes be about impugning a scientific system that's been poorly designed or that has evolved into a sort of ineffective or biasing shape over time through nobody's intentional effort. But those things have to be critiqued so that people can trust science.
Hmm.
I think a lot of people want people to trust science because we say, if you don't follow the latest thing, you're anti-science. It's like, I don't know, bullying people into accepting your statement isn't the same thing as persuading them that that you deserve their trust. If you want people to trust scientific institutions have to act in trustworthy ways, which means like, you know, publishing open data, showing how they did their reasoning, um, you know, being honest when they made a mistake and retracting the results and so forth. And, there's a lot of wagon circling among public health officials and so forth, where it's like, basically just do what we say or you're anti-science. But that's just a form of rhetorical bullying that isn't persuasive. And it isn't the basis upon which someone should trust a medical authority.
Well, and what it does is it relies on, you were taught Newton in the seventh grade. We're just like Newton. And it's like, no, you're not. This has been tested and tested. People tried to disprove him for centuries, and it's only with, and it's basically functionally true on the Earth. Most of his stuff, it's that his paradigm doesn't work at really big or really small places, and so we have to have a whole
Or at
different
really
kind of
high
physics,
speeds.
right? So we have to, and it's not like Einstein rejected Newton; he moved beyond him, and it's like, this is the process of science, and that's why you can trust it. Because it's verified over and over and over. When you come out and say something changes multiple times, that's normal science, but you don't trust each one of them as being Newton.
Yeah,
Like,
so part of it is that there does have to be a public education component to this, which is that people have to understand that a scientific report is not a fact; it's a progress report. It basically says,
right.
here's the evidence that we have for this now, and we might have different evidence later. And then as a consequence of that, we might update our policy, or we might update our current consensus about what we think the view is. So of course it's true that people in the public have to understand that science correcting itself and updating its views and so forth means that science is working. But often they get, especially when you get media articles that say like scientists have proven blah, and then
Right.
2 years later, like scientists have shown this opposite thing. Then people are like, well, what the heck? I thought that was proven this other way. Does that cure cancer? Or does it like cause cancer? And so that's a public misunderstanding about what science is. But that's not necessarily at the feet of the public to resolve. That has to do with people who are in a position to communicate about science.
Well, but it also, that I think that's exactly right. But it also then shows the burden upon the transparency of the science. I thought this in graduate school, where you would read 3 or 4 articles and it would be like they all come to the exact opposite conclusion. One of them has to be wrong, but they all got published within like 2 years of each other, and neither one of them actively came out and said, I'm refuting so and so, because academics are polite people and stuff. But there has to be a fundamental problem. Why aren't you publishing? Wouldn't it be far more useful for the enterprise of science to know where dead ends are, to know which models are not useful? Why are we not having publications dedicated to this? I could see the constraint when we were publishing things on paper, but now, what the amount of space that takes up on a hard drive is like, it's not worth even mentioning. So why are we not engaging in this enterprise? What is the reluctance? Is it a pride? Is it a vanity? Is it a prestige problem? Because everyone does this, right? I mean, as a scientist, there are plenty of things that you will do and they don't work. Why is that not just as useful data as finding the stuff that does work? And why isn't that also worthy of being distributed?
There are some measures in place to try to address this. So there's a movement now towards something called pre-registration, where you basically publicly state, here are our hypotheses, here's the statistical analysis we plan to do, here's exactly how many data points we're going to gather before we stop collecting more data, here's our criteria for excluding data for being an outlier. And then you run the study, and then ideally what you should be able to do is to write up the results no matter how they come out, because you've committed yourself, pre-committed yourself to doing so. Unfortunately, at least with, say, clinical trials, there's something called clinicaltrials.gov, which is supposed to be this. It's that if you're going to do a clinical trial, you have to register it with this government repository. You have to say, here's what we're going to do, here's our exclusion criteria, blah, 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 blah. But it's still the case that even though it's, like, I think illegal, many researchers who run the study and don't get what they hoped according to the pre-registration just don't bother to write it up, and sort of nobody really seems to follow up on that as a matter of practice. And so there are, in principle, ways of addressing this, and pre-registration is becoming more common in social science and medicine, but it still hasn't become kind of the default.